in this video. Section 3.3, the quadratic formula. Okay, so first we'll go ahead and we'll state the quadratic formula. Given an equation of the form ax squared plus bx plus c is equal to 0, then the solution is x is equal to minus b plus or minus, let's see here, b squared minus 4 times a times c. This goes under a square root, and this right here gets divided by the quantity 2 times a. Okay, and note this form here. This is standard form for a quadratic. And our quadratic equations must be in this form if we're going to use the quadratic formula. As an example, let's take a look at the equation 2x squared minus 3x minus 4 is equal to 0. X will be equal to minus a minus 3 plus or minus, let's see here, minus 3 squared. The negative sign goes inside those parentheses. It gets squared as well. This term is always greater than 0. I don't care what b is. If it's a real number, it's greater than 0. Let's see here, minus 4 times a, that's 2, times a negative 4. We'll take the square root, and we'll divide it by 2 times a. That's 2 times 2. Now, we get to start simplifying. Hooray! So, this is equal to a positive 3 plus or minus 9. Let's see here, this is 8 times 4, so that's plus 32. And we'll divide it by 4. Take the square root of it. And we can go ahead and we can add this. So, we'll have 3 plus or minus the square root of 41 divided by 4. And that's our solution. This isn't a perfect square. We've done as much as we can with it. Anything more would be an approximation, and we're just not interested in those. Back to the equation, this right here, change colors, make it pop. B squared minus 4ac. This is called the discriminant. And we need it simplified like this. Let's take a look at another problem, but this time we're not going to start in standard form. We're going to have 3x squared minus 4x plus 2 is equal to 2x squared minus 6x plus 7. Okay, we need it in standard form. That means that this better be 0. I need to have equals 0. So to get it to be equal to 0, what I want to do is I want to subtract by every single term. And to do that, and to keep track of that, I'm going to go ahead and set this up. Rewrite the left-hand side, and then write the right-hand side below it, but without any signs. Next, I'm going to change the sign of every term. Positive 2, negative, negative 6, positive, positive 7, negative. So what I'm doing is I'm subtracting the entire right-hand side from the left-hand side. 3 minus 2 is a single x squared. Minus 4 plus 6, that's plus 2x. 2 minus 7, a negative 5. And hey, look, this guy got subtracted from over here too, or it's not equal. So this is equal to 0. Pretty cool. If we wanted to write that explicitly, even though we don't need to, we would say, hey, look, they're equal to each other, which means that if I subtract 2x squared, add 6x, and subtract 7, they're still equal to each other, and this equation, or expression, excuse me, comes out to be 0, whereas this difference comes out to be that. Either way, we now have this in standard form. So if we wanted to, we could go ahead and take note that A is 1, B is 2, and C is a negative 5. Then we put this in the quadratic formula. So that's minus b plus or minus b squared minus 4 times a times c. Take the square root and divide it by 2 times a. Okay, so why did I bother with the multiplication by 1? Because I don't want to forget it. It's a good habit to get into for the cases like our first example over here, where a is not 1. Every time I write out the quadratic formula, I start with the full thing before I start to simplify. Likewise, I always put these parentheses in. Always write out the full fraction bar every single time, the full square root. I don't leave off the plus or minus. It takes a little bit more time, but I don't mess up. So now we'll start to simplify. Minus 2 plus or minus, all right. So that's 4 plus 20 divided by 2. Why do I do the square root last? Because I don't know how long that's going to be, and I don't like to have extra square root hanging off over in this direction. So we can still simplify. This is minus 2 plus or minus the square root of 24 divided by 2. And that is x. Hooray. Quick note on simplifying these guys. Yeah, 2 and 2. We should be able to divide, right? But if we do that, it would still have to be plus or minus the square root of 24 divided by 2. Oh, well, no big problem, right? Can't I just take this 2 and, I don't know, divide 24 by it and get like square root of 12 or something? No, I can't. This is a square root. It's the inverse of a square. That's an exponent. And the order of operations goes parentheses, exponents, multiplication, addition. If we were to do this, we would try to be cheating when we try to put m in front of e. That doesn't fly. Okay, it's been a few videos, but it's time to spice things up a little bit. Here's a nice, long, complicated, involved problem. There's a lot going on here. I've got a binomial squared. I've got a product of two binomials, and I've got some addition happening too. Before we deal with any of this addition or getting this guy in standard form, we're going to have to expand these binomials. Pepper, you're in the way. And first thing I'm going to do is square. Now, if I am going to square a binomial, we're going to have a squared, so that'll be 4x squared, plus 2ab, so that's 2 times 2 is 4, times a negative 3 is a negative 12, times x, plus b squared, and then the 3 will just hang out, so that's plus 3. And this is going to be equal to this product here. We're going to distribute here, x times x, that's x squared, x times 2 plus 2x. Then we'll do the negative 3 minus 3x minus 6, and the minus x hangs out. Okay, now let's do some combining. On the left hand side, I can't combine this, I can't combine this, but I can combine 9 and 3. They give me 12. So this will be a positive 12, a negative 12x, and a positive 4x squared. And that's going to be equal to, well, I can't combine x squared with anything. I can't combine negative 6 with anything. but I certainly can combine all three of these guys. That's 2 minus 3 minus 1. That's 2 minus 4, a negative 2. Minus 2x. Okay, so we expanded, we combined. Now it's time to take the difference and get this guy in standard form. We'll do that like we did previously. We'll start by rewriting our left-hand side. Then we'll rewrite the right-hand side, but without signs. Now we'll change all the signs on that right-hand side so that we're taking a difference instead of just adding them together. The results of this difference: 3x squared minus 10x plus 18. And that's going to be equal to 0. Now it's quadratic formula time. So we'll take note of our coefficients. A is 3. B is a negative 10. We always want to be careful of these signs. C is a positive 18. Let's put them in the quadratic equation. X is equal to minus a minus 10 plus or minus, let's see here, that's negative 10 squared minus 4 times 3 times 18. This is going to be a fun product to take. We're going to divide it by 2 times 3. Okay, now we can start to simplify. So that's a positive 10 plus or minus 100, and then this will be 12 times 18. Do a little scratch work. 6, 1, 3, so then 8, 1, hey, 216. Minus 216, okay. And we're going to divide it by 6. So the result will be x is equal to 10 plus or minus the square root of negative 116 divided by 6. Yes, this is less than 0. But we still want to simplify the discriminant. Our solution is still in this simplified discriminant form, even if it's not a real number when we take the square root. Okay, that's it for section 3.3. Thanks.